Alrighty, let's get started. So, we are officially in week 7, right? Link lists. Any questions about anything so far? Anything we've done? Going once, going twice. Okay. Link lists are the 1, 2, 3, 4th data structures that I'm going to tell you about. First one was the bag, then we talked about the stacks and the queues, and now we're going to tell you about linked lists. And linked lists are a data structure similar to an array in some ways. Okay, so to look at a linked list, look at this thing right here. Right, so you have basically a bunch of links, and each of these links is going to be an object. Okay, each of these links, so each object is going to have a field, 2 fields, or 2 variables. Right, one variable is going to be for some kind of a data, and to keep things simple, we're just going to make it integers. Right, so each link is going to store some kind of a number, like 10, 15, whatever. Right. And then each link is going to have a variable of its own type, which means that this class link is going to have a variable of the link type, which is going to be called next. And what this variable here is going to be equal to is another link, right? And then that other link is also going to have a variable of its own kind called next. And that next one is going to be equal to the other one after it. And then the other one after it is going to be equal to the one after it. And the very last one, the next on the very last one is going to be equal to no, right? No is basically like a pointer to nothing. Okay, so that's that. And and then the whole thing is going to start with some kind of a class called linked list, and then in that class is also going to be a variable of the link type. So this is going to be another link, which is going to be equal to the first link. Okay, and this is just one type of a linked list. So why have a linked list? Well, first of all, now you have a data type of your own, making. Right? An array is always just a list of integers or a list of characters or a list of doubles or whatever, right? And what a linked list is, you basically define your own data, if you will, right? So each link can store all kinds of information. It can store integers. It can store just a bundle of things, right? So each of these links can be some kind of a really, really, big memory object in memory if you wanted to. Not these though. So other than making a list of whatever data type that you want, you can do some things faster and easier with linked lists than you could with arrays. So remember that if I had an array, and at least the way we've been doing it, and I wanted to delete something from this array. Let's say I wanted to delete the first thing, right? What I have to do is I have to shift the second one to the place of the first, and the third one to the place of the second, and the fourth one to the place of the third. And if I have 1,000 or 1,000,000 things, there's a whole lot of shifting that has to be done if you're deleting something, right? And similarly, if I wanted to insert all the way at the front, then what I have to do is I have to start at the last one, and the fourth one is going to shift one place to the right to the place of the fifth. Third one moves to the place of the fourth, second one moves to the place of the third, first one moves to the second or the first, and then you can insert a new one. So all that shifting again takes a lot of time, and if you're talking about an array of really big objects, not just an array of just basic integers, then it's going to be very time consuming to shift all these huge monster objects around in memory. So how is a linked list better than that? Well, for linked lists, you do not have to do all those shiftings at all. If I wanted to insert a new link all the way at the front, what I have to do is I have to say, okay, well, this new link is going to connect to this one. Oh, actually, no. So if I wanted to insert a new link in front of this one, I'm going to say, okay, there's going to be a new link which is going to point to this one. and then I'm just have to tell it, okay, this first link now points to the new link. So first one is going to point to the new, and the new is going to point to the old first, and that's it. So I just have to do 2 connections, and I have inserted into the linked list. If I wanted to delete from the linked list, it's actually even easier. Let's say I want to delete this link right here. All I have to do is just say, okay, well, we're going to grab this pointer, which used to point to first, and I'm going to connect it, and instead of to this one, I'm going to connect it to the one after it. And that's it. And then the link is basically no longer in the linked list. One thing that we have to watch out in C++, unlike Java, is memory leaks. Okay, so we can do the same exact thing that that you're seeing here. We can do it in Java, and in Java, as soon as you basically connect this first link to the second link, or as soon as I connect this link to the second one that's here, then this link that is no longer part of the list is just going to kind of be floating around in memory. And if it was Java, the Java virtual machine has something called a garbage collector, and that thing will eventually grab these objects that are floating around in memory and just clean them out. Okay, but since this is C++ and it's not a very nice language for that kind of stuff, you have to deal with deleting these objects that are floating around in memory. If you don't, what you're creating is something called a memory leak. Okay, and that is the event where your program just keeps sucking up more and more memory and never releasing it. So I just keep making new links and new links and new links, and more of my system memory of my RAM is dedicated for my program, which never released these places in memory. So what you have to do is you have to actually really delete the links since this is a C++. Okay, so insertion. The moral of the story is insertion and deletion is very fast in a linked list. You can make a linked list of any data type, but I guess you could do the same thing with an array. Okay. Another advantage of a linked list is that other than deleting and inserting quickly, it can change in size to whatever you want it to, right? So initially I start with a linked list of nothing, then I add one link if I wanted to, then I can add another one, and then another one, and I can keep adding as long as I have memory, system memory. Okay, so it's basically an array. If you could create an array which shrinks and expands by as much as you want it to, that will be kind of one of the reasons why we create linked lists. Okay, and yes, there's some newer data types. There's vectors, there's array lists and stuff like that came at some point, but what we want to do is we want to create these from scratch. Okay, and we're not going to rely on some built-in data type that's part of the language. I want you to create it yourself so that you know how it works. Okay, so third advantage of a linked list is it can shrink and expand by just one every time, so you can expand it to as much as you want. Okay, some data types like vector, there's a vector data type which is similar to a linked list, to an array. So the vector is similar to an array, but let's say you start with a vector of 2, right? And you filled it up with 2 things, and now you're trying to add a third one. As soon as you're trying to add a third one, the vector will know to double itself in space. So it will go from 2 elements to 4 elements. But what if you don't need 4 elements? What if you only need 3? And then later on, when it goes to let's say maybe 16 or whatever, and then it will try to double up or increase its own size by a certain increment, which is not always going to be by +1. And again, that's why we want to use a linked list, because it will be exactly as big as you want it to. There's nothing in it, it's a blank list. If you want to add 10 things, no problem. You can just keep adding as many as you want. So insertion is quick, deletion is quick. You can make your own data type of whatever you want, and you can shrink it and expand it by however you want, by exactly however many elements you want. Now, there are disadvantages to these linked lists, and that is if you wanted to go to this last one. Right? The only reference for this particular type of a linked list here is a pointer to the first link, right? And the only way for me to get to the first link is starting at this one right here. So if I start at first, I can go to the second. At the second, well, actually this is your first. From this pointer first, I can get to the first link. Then from this link, I can go to the second link. Then I can go to the third link. And only then I can go to the fourth link. So in order for me to get to the last one, I got to hop through all these other ones before it. So going directly to a specific link in the linked list is much more time consuming than an array. Because an array, what could you do? If you want to go to element 999, you put square brackets 999 and you go jump straight to that element. In a linked list, if you wanted to go to element 999, you're going to have to hop through 998 previous links. So for some things, for some operations, linked lists are not a good idea, right? If you know that you're going to be jumping to a specific thing, then choose an array data type. But if you know that you're going to be inserting and deleting things, then linked lists would make sense. Also, if you want to make something that expands itself in size as you need it, that will be a linked list. Okay, so that is linked lists, and I have plenty more to tell you with the actual how it works. The chapters that you can read are Lafore chapter 5, talks about linked lists, and Karanov 4, 8, and 9 chapters also talks about linked lists. Okay, so that is that. And the next thing is, let's have a look at what I have for linked lists. So what I've used is these two textbooks to kind of sum up the useful information. So the efficiency of arrays, right? Getting to a specific element. It was very efficient, right? It has a big O of 1 notation, so it's big O 1 is basically constant time. So it's very quick to jump to a specific element, but searching is depending on how many things you have in the array. It could depend depending on what kind of a search algorithm you have, could have different efficiency. Depending on what kind of a search you're doing, right? There is a binary search, there's linear search. So a binary search, for example, for 100 numbers, you can guess the thing in approximately 7 guesses because you're going to keep dividing the guess every time by 50 or divided by half. Linear search, if you're trying to search through an array of random order, the first time you might guess 99 times for 100 numbers to guess the correct number. Second time, maybe you guess 1 time and you get lucky. But if you do it many, many, many times, then the linear search, the average time will be about half of however many elements you have. Okay. So that's what this is about. And yeah, so linked lists. Let's have a look at the linked list. So like I said, you're going to have a class which is called link, right? And inside that class, you can see here, so this is my class link. And for that class link, I have a pointer. Remember, I told you we're going to be using pointers all over the place. So now we're creating a pointer to another link, right? So this is a link pointer called pNext. So that's it. So that is what next is. This is the field next, right? In there we have a couple of numbers, integer data, double data, right? Just some kind of an information that's going to be stored in the links. Okay. And this this pointer to a next link is sometimes called self-referential pointer. Okay. And again, this is a data structure defined by relationship, not position. You cannot jump to a specific position in a linked list. I can't go and tell it jump to number 999. I have to use the relationship of the links in order for me to jump from one to another, to a third, to a fourth, in order to get to the actual one that I want. Okay, question?
Yeah, on the previous slide, can we go back one? Where you were defining the self-referral.
This
what
one?
was that referring to actually?
This one?
To the next? To the
Yeah.
next.
So this is, you have a link asterisk p next, which is of the class link type. So it's basically, it's a variable. The class link has a variable next, which is of its own link type. That's the self-referential. So it's like a variable that can point to itself. I could make next equal to the link itself, right? So I can actually have one of these links. I can say instead of next is equal to some other link, I can tell it next is equal to itself. It can point to itself too.
So in the case when there's only one link.
Yeah, if it's only one link, well, in this particular type of a linked list, you would want the next to be equal to no, right? So the last thing in the linked list should point to no. That's how you know where it ends. Okay, but if you really wanted to, you can make it equal to whatever you want. Make it equal to itself. So then the link is going to point to itself. All right. Yeah, and then what this is here, what this one's, this other class that the author shows here is basically you, instead of having the data like double data, integer data, or whatever, you can have all kinds of different data in the link. You can actually have another pointer which points to just the data type, the data that is going to be stored in the link, right? So one of the pointers points to the next link so that you can connect the different links, and this p item pointer could point to some kind of an item class which holds all the different data, right? The I data, the double data, the name, or whatever, right? So that way you break down into different pieces, what kind of information is in what part of the code. Okay, so that's that, and let's have a look at this thing. So this is my class link, right? In that class link, I have public data, double data, integer data. Yeah, I have my constructor, right? This is my pointer variable pNext, which is of the link type. Okay, and then as soon as I create a new link, I'm going to give it specific values. So I'm going to give it a new value for iData, which is equal to ID. And I'm going to give it a new value for double data. DData is equal to DD, right? And then initially, each link, as soon as I create a link, I'm going to set that pNext is equal to no, okay? And no refers to nothing, right? So it's basically, it's like a null pointer, okay? So, and yeah, so initially the link is not connected to anything, but it has some kind of a data put into it. And then the only other method that is part of this class is the display link, which is going to show us those two fields, the DData and the iData. Okay, so that's all the class. So that's the only thing that a link can do. And the reason why we don't have more methods is because or the author decided to make these variables to be public. Okay, so that means that I will be able to directly access any link's variables directly with just using the dot. So if I say new link, say I make a new link called temp link, right? If I wanted to change the data for temp link, I can say temp link dot iData equals something else. If I wanted to change the link of temp link, I say temp link dot pNext is equal to something else. So this is why I don't need dedicated methods to be changing these different variables, which is what we actually were doing up to this point. Okay, it's just to reduce the amount of methods and to simplify things a little bit. Okay, but ideally you should have these as private, and then you should have public methods that change these, variables or properties, just like we've been doing. Okay, so that's that. And then we have your LinkedList class. Okay, so the LinkedList class is just basically a way for you to manipulate these links. And by that I mean it will mainly serve as a reference to where this whole linked list starts. Okay, so what does the linked list class have? Well, it has a link variable called pFirst. So as you can see, this link pFirst here is similar to how we have a link pNext there. So they're both links, right? So both variables are of this class link type, right? And that's why if you see the picture here, right, that's what I was telling you, that this first here, right, so this is the linked list class, which has a variable first, which is a link that is equal to the first thing on your linked list, and then the first thing on the linked list has a variable link called next, which is equal to the next thing, and so on and so on and so on. Okay, so this is my linked list, and what is the linked list class is going to do is, as soon as I make a new linked list, I say that the first is equal to null, similarly to how I did it with this here, right? I said p next is equal to null. So as soon as I make a new link, I connect it to nothing after it, and as soon as I make a new linked list, I say that there's nothing in it. It does not. The p first is equal to null. That means it's an empty list. And that's why we have a method here is empty, which returns p first is equal to null. So it basically returns true or false. If the list is empty, returns true. Okay, false otherwise. And now let's have a look at this here, which is how you insert into your linked list. Okay, and don't worry, I'm gonna have the complete program down a little bit later. This is just like the different pieces of it. So these are some of the other methods that are part of my linked list. Okay, when you start writing these, what you should do is just write them incrementally as one little method at a time. Okay, remember method, function, same thing as far as we're concerned. Okay, so anyway, what does insert first do? Well, it takes two values, integer variable value, double variable value, so two numbers. And then it's going to create a new link. So new link is equal to new link, and then we're going to put the ID and the DD in there. What this is going to do is going to call my constructor up here, this one, right? And then we're going to pass those two values, and we're going to make a new link with these specific values. So far, so good. So we're going to make a new link. We're going to give it the values from the constructor, from the constructor of the link. So that's it. So I create a new link with a specific values. The next thing I'm going to do is, and we're assuming that we're inserting at the beginning, right? So that's why it's called insert first. Okay, so first thing we do is we're going to say p new link is equal to p new link next. This is how we access the variable next that is part of my link, the new link, right? So by doing this, p new link with this little arrow here, p next, I'm actually accessing this variable right here. Okay, so this is how I'm going to make this variable here equal to some other link. And this is how I'm going to establish the connection with the different links. Okay, so I'm saying that the new link, so this is the first step, right? So p new link next is equal to p first. And I have a little number here. This is step 1. So step 1 is, suppose you had some kind of a linked list like this initially, right? This is your linked list. You had one link that had a value of 42, another one that had a 7, another one that had some other number, and then the very last one, the next field of it is equal to null. Okay? So the first thing that I need to do is, this is my new link. Let's say that one is with a value of 33, right? I have to establish this connection here. That's the one, right? So the first thing that I do is I say this new link next is equal to this one, okay? And that is this right here, okay? So p new link next is equal to p first. What is p first equal to? Well, p first is equal to the first link. So whether I say first or I say this link right here, the very first one that's got a value of 42, it's the same exact thing. So when I say p new link next is equal to first, I'm actually saying that it's equal to this link in the very beginning, which is how I'm establishing this connection, right? So that's the one. Okay, so I'm establishing this connection. So the new link now next here is equal to this particular one. So we established this relationship. The next one is I say p first is equal to new link. So now what happens is I move this arrow that you're seeing here, so this is no longer equal to this link. Now it's equal to the new link. So I have established this connection. So first I establish this connection, and the order of things matters. Okay, and that's why I recommend that as you're working through these, try to create this thing by just drawing out the different connections on paper and then seeing how you're supposed to do it, and then doing it. And then once you do it, show the list. Okay, so make sure that it inserts itself in the correct spot. Okay, so any questions on this?
Where did 33 come from?
33 is we send the value of 33 in here when we called it, right? So whenever we called insert first, we put the value of 33 in here, and that's the value of 33 that got sent into the link constructor, and that's why it's equal to 33.
So the first one is 33. The one that says 33.
Yeah, the one that we're inserting is 33, and so initially this one here first is equal to this link, which is a 42. After the new connection, first is equal to this link.
33.
So now first is actually equal to 33.
Okay.
Okay. Remove first, right? How are we going to remove first? Let's see if I have some picture in there. So this is what it looks like initially, right? So we have some kind of a link 27, and then we have some other link 94, then a 6, then a 33. What we're going to do is we're just going to get first, and we're going to tell it connect to the one after it. Okay, now how do we do that? You're just saying first is equal to first next. Make sense? It might look very easy, but unless you spend the time looking at this and actually, drawing it on paper and getting it to work, visualizing what happens, this is not something you can do in your head. Okay? And this is super important because when you're getting a job, chances are they're going to be asking you something with linked lists, something with data structures. This is very, very important, which is why I'm spending 3 weeks on this stuff. Okay? So any questions on deleting a link? So all I said was, I said first, next, or no, I said first is equal to first next. In other words, I'm saying that this one here is equal to this one here, which is actually equal to this one. So that is how you establish this connection. You're just getting rid of this link. You haven't gotten rid of it, but you're just making that connection. And the code here, right at the end, is where you delete the temp. Okay, so ptemp is equal to first is equal to first next, and then you delete ptemp, and now that link is gone. Okay, that is the getting rid of this memory leak that we're talking about. Okay, so this is deleting a link, displaying a link. Displaying the list. How are you going to display the list? Well, all you have to do is you have to start at the beginning, right? You're going to start at the first one. You're going to make some kind of a variable current. You're going to make current equal to the first one, and then you're going to tell it, okay, well, show the first one. Then current is equal to current next. So now it moves one down. Show that one. Then you tell it, okay, current is equal to current next. Now it moves one down. Show that one. Then you tell it current is equal to current next. It moves one down. When it gets to the no, as soon as it gets to no, you stop. That's your trigger that you got all the way to the end of the list. Okay? And that's what happens here. So you have some kind of a link, which is called current, which is equal to the first. You have a loop that goes on until current is not equal to no, or until you get all the way until at the end. You're showing every link, and then you're telling current to move one down. Okay? And that's it. Any questions? So the display is not very difficult, but again, draw out like some hypothetical situation with a bunch of links, pretend that the current is in the beginning, and then try to visualize what happens every step. Write it out on paper, draw the pictures, draw the links, whatever it takes. Okay? So that's what happens. That is how you go through the list. Okay, and this is now with the linked list with a couple more methods added, right? So initially we just had a constructor which makes the first equal to no, a way to check to see if the thing is empty. Then we added the insert first. You can also get first, right? You can get the first link so that you can see it if you want to. You can remove first, which is what we just did. So we did insert first, we did remove first, and then the last thing we did was display list. And that's it. Basically, that is in a nutshell, very simple linked list. And this is how we're going to do it. So you're going to have a main in it. You're going to create a variable of the linked list type. And what is this variable of the linked list type? Well, remember, this is what the linked list is. All it has is just a single variable of the link itself. So it's just like a glorified container for your first link. That's all there is in the linked list. It's just one link called first, and that's going to be set eventually equal to some other new link. Okay? So that's it. So we make a new linked list, the list. In it, there's a first variable which is equal to no. Then we start inserting the first one. So the list, insert first, 22,299. These two, right? We're going to send them into insert first. This is my insert first. Then insert first sends them over to the link constructor, and we basically create a new link called pNewLink with these specific values, the values of 22 and 2.99, right? And what else? So pNewLink next is equal to pFirst. What was pFirst initially? Well, we didn't have any links. No. Right? And that's what I'm saying. It might seem very easy or very trivial as I'm talking to you about it. It might seem easier just by looking at the program, but if you actually try to do this yourself to visualize how it works out, you have to do it on paper. It's just very hard to keep track of these in your head. Anyway, so first initially is equal to no. Why is it equal to no? Because that's what we do with the constructor, right? As soon as we make a new linked list, first is equal to no. So as soon as I add my first link, so that first link was with the value of 22, I'm telling it the new link next is equal to no. Okay, and then first is equal to the new link. Okay, so now first and the new link are both equal to the same thing, and the new link next is equal to no, so that's where it ends. Okay, that's my first link. Then I'm going to go and I'm going to add another link, the link of 44. Okay, so the link 44 now, we already have one link, right? That one link, first is equal to that one link, okay? And then pNewLink next is equal to first. So now we're making a new link, which inserts all the way in the beginning of the linked list, right? That's why the new link next is equal to the first link. And then now the first link becomes equal to that new link that you established. So the new link is connected to the old link, to the old first link, and then the pointer to the first link changes to the new link that you insert. I know it's a lot of words, and that's what I'm saying. You gotta write it out on paper. Okay. I'm not sure if I have any drawings in here. No, I don't. Okay. Maybe I'll add some drawings in there to show you how the insert first works. But the drawings were basically, what we're doing is we're doing this stuff here. Right? That was kind of like the explanation why I don't have a whole lot of drawings. Okay? So that's how we insert a bunch of links. Right? So every new link that we insert here, right? We're putting it all the way in the beginning. We're connecting. First thing we do is we're connecting the new link with the old first link, or the old link 1, and then we're telling first, the pointer to first, to connect to the new link, right? And those are the two steps that were, what were they? Right here. So every new link, we're doing these two steps, right? We connect the new link, we connect to the new link to the first one, the old link 1, then we connect first to the new link, and that becomes your new link 1, basically. Okay? So this is inserting the links, and then I have a loop in there that is while the list is not empty, right? We know how that works. We're going to create a new temporary link, which is going to be equal to the get first. And what get first does is it just gets you the first link. Then we're going to show that link, and then we're going to remove the first link. So we get a link, we get the first link, we show it, remove it from the list. Okay, and then remember how remove first works? It's right here. So all the remove first does is it creates a new temporary link so that you can delete it, and then it tells first is equal to the next one after the first. So and then you delete the link, and then the link is gone. Okay? If you did this, if you're doing this in Java, there's no delete part in the Java class. Okay? Java does the deletion automatically. Okay? In fact, in Java we don't really need to do temp link at all. We just say first is equal to first next, and now first has been removed, which is why I like Java better than C++ when it comes to data structures.
So we're not using the dot operator here, like when you say first is equal to p first. Usually we'd say p first dot next, right?
Right. You could it's just a syntax. So the little dot. You could use the dot in C++ also, the way you do it in Java, but this is basically like the dot in Java. All right, so this little arrow that we have in here, the dash and greater than, that is like the way that Java does it when you have an object dot something, right? Which is, I think, something we did also, right? Right, with the Exhibit, the dot allows you to change the variable in there. If we change this thing to an ampersand sign, then I have to change the syntax a little bit, but then you can change this arrow to a dot. So there's multiple ways to do the same thing in C++, but I'm just sticking with that syntax for now. Okay? And the reason why this thing is a pointer is because first is a pointer. You can only make apples equal to apples. I can't make an integer equal to a string, so I need to have a pointer of the link type be equal to first, because first is pointer of the link type. Okay, so and then we remove a bunch of links, and then you can display the list, and you can see what it looks like. And display list will look like something like this. Okay, and that's what I'm saying. As soon as you write one method, so actually the first thing you should do is write the display method, right? Display list method, so that you can show the things. Then try to insert something, right? Remove first. There's one thing we could add in here is to check to see if it's empty first, right? This is something that we actually checked inside the main. So the loop went on while the thing is not empty. But ideally, inside remove first itself, you should have some kind of a failsafe to check to see if there's no links. Don't try to remove something, because this thing is going to crash on you. That's how C++ works, right? So that is a linked list, and finding and removing specific links. Okay, so finding a link is very similar to displaying the linked list, right? So look at the display. The display list is you have a current, and you're telling it, wow, current is not equal to no. Then you tell it to move down. P current is equal to P current dot next, and then you display every link along the way. Okay, well, look at the find. The find is kind of similar. You're still starting at first, so current starts at first. This loop goes on while you haven't found the data, but there's an if in there, and if current next is equal to null, you just return null, and then that's it. Okay? So basically, if you get to the end of the list, if current is the last link, then current next is going to be equal to null, and if that point you have reached the end of the list, and you can get out of the list and return null. Okay? Otherwise, you tell it go one down. Okay? And then the loop, of course, is going to stop as soon as you get to the point where the data of the current link is equal to the key, and then at that point you return the link with the value that you're looking for. Right? Questions? I know it's a lot of words. It's a lot of words. It's a lot of information. It's dense. And again, do not underestimate this, because it's going to kick your ass. I'm serious. That's why there's a reason I'm doing this for 3 weeks in a row, because it's very important. You gotta, don't just write out the code and say, all right, I got this. No, write it out on paper. Like, you can write the code on paper or not, but draw out the linked list. Start with nothing, then add a link, then add another link, then add another link. Do it like 3 or 4 times until you get comfortable. Then start removing links. Okay, then see how the find works. Okay. And if you want to come see me in my office or for me to draw you some drawings so you can see how it works, I'll be happy to do that. Okay, and I've had to do a few drawings this semester for some very smart people. Okay, it's not an easy concept. Okay, so that's that. So this is now we're testing finding a specific link, right? And then in here I have if find is equal to no, you didn't find it. Or if find is not equal to null, that means you found it and you can show what it is, and otherwise you can say they didn't find the link. Okay. Then we also have a remove. Okay. How much more do I have of this thing? I'm almost towards the bottom. Okay. So the next one now is we're going to remove a link. Okay. And just to make things easier, what I do is I create two variables, right? One is called current, one is called previous. Okay. The reason for this is because my links are not double linked. My link list is not double linked, which means that the only way for me to move through this list is in one direction. I started the first and I move left. Okay, I can't, if I get to like say I'm trying to delete this one here, right? I'm trying to delete the 98. Once I'm in the 98, there's no way for me to tell it, okay, go one back. That is the reason why I have another variable called previous, which is exactly one link behind current. Okay, so the way it's going to work is this. We're going to tell current and previous to start moving down the list. Okay, previous is always one link behind. Okay, let's say we're trying to delete the link 98. Okay, we're trying to delete link 98. We're going to tell current, okay, start at first and move down until you become equal to the key value, right? So as soon as current becomes equal to the value of 98, which is what we're looking for, I'm going to tell it, okay, forget about the current, go look at the previous and tell the previous to connect to current next, right? So I'm going to say this here, previous next is equal to current next, and that is how I'm going to establish this connection. And that is right here. So this is basically, if you get to the end of the list, you exit with a null, return false. Otherwise, what you do is you tell it previous is equal to current, right? So now, as soon as you say previous is equal to current, both of them are equal to the same link. Then you say current is equal to current next, and now current hops one link down from where previous is. Okay? And if current is equal to first, so this is there's a couple of different ways. So this is if you found the link that you're trying to delete to be the first link, right? If that's true, all you have to do is you have to tell first go one down, right? Because first is the link that you're trying to delete. Just tell it move one down, and then you delete current, and then that link is gone. Otherwise, if you did not find that 98 to be the first one, then you do the previous dot next is equal to current dot next, which is what I was telling you, right? You're telling it previous dot next here is equal to current dot next, which is this link. Okay? So you either find the link in the beginning and you tell it, okay, well, this is the one I'm going to delete. So then just tell first is equal to first next. So connect first to this link now. Or if the link is somewhere in the middle, then you need the previous to be connected to the current next. So previous dot next is equal to current dot next.
Should be 73 then, right?
Yes. So this one, the next here, the previous dot next here is actually equal to link 73. So if I wanted to look at this link or this link, they're the same exact thing. Okay? So that's that. And what do you have to do? Fun things. So write the complete link list shown pages 1 through 14 above. All the methods that you saw, right? Draw some pictures if you have to so you can see how it works. Test the link lists. Show your results. And then add the following 3 new methods to the link list. One is going to be sum the data. So as you're going through the linked list, add the sum of all the data of the I data. So we only care about the integer data. Forget about the double data. You can even skip it if you want. Okay? And by skip it, I mean don't even have it in the link if you want. That's no big deal. Okay? Min is going to do the same thing, basically going through all the links, finds the smallest. You should, by now, having taken my classes, you should know how to find smallest, right? And then num links. Count how many links we have as you're going through the list. And that's it. So this one is actually not very difficult. Most of these, well, all of these are pretty much similar to how you display the link or display the list, which was going for it, finding it. Where's the display link? This kind of stuff, right? All you're going to do is you're going to make current equal to first. You're going to tell this thing to go around the list. Current is equal to current next. Until current becomes equal to null, then the loop stops. So you just use your display list to create all these different ones using the things you already know. Okay? Sum of links, min, and the number of links. Okay? You can easily write them all in one method, but let's do 3. Okay? Any questions?
Does this take a while to learn? I feel like.
It does.
Yeah.
That's what I'm saying. You got to write it on paper, and like don't just like. I mean, unless you're some kind of an exceptional audio learner, maybe you can grasp all this stuff that I said. But I don't think I could. All right. So what you do is, what I would recommend is print out the different parts of this program. So print out, print out the link, right? Go to the link, which was all the way at the beginning. What was this thing? So print the link first. So you have like a piece of paper with the link sitting there staring at you. So you don't have to worry, oh wait, what's happening? Oh, okay, look, this is what's happening. Then you go in there and you do another separate piece or a couple of pieces of paper that show you the linked list class in all its glory. I mean, all these different methods that are part of it, right? So all this thing, that's another piece of paper, right? That's sitting there, okay? And then as you're starting to work through the main, that's where you start drawing things out. Okay, now this is, what are the values of the list when this whole thing starts? Well, the list itself is just one of these, right? And what's in this? Well, it's just a single link. So the only thing that the linked list is going to be equal to is some other link, right? And then you just examine the values of that link as you're adding more links, as you're inserting, removing, searching, and all that good stuff. Okay? Yeah, and that's it. So this is that's the drill for this week. What we're going to do next week is we're going to have a circular list. And what is a circular list? Well, the circular list doesn't end with a null, right? All these other, every list that we saw up to this point, or this is just basically one type of a list, ended with a null. The circular list, instead of having no at the end, it's going to have this last one go around and connect all the way back to that first one. And then we're actually going to also say that there's no first to speak of, because there's no beginning and an end of this list, and that first can be just some kind of a variable that moves around the list. Okay? So that'll be the next step in complicating things a little bit. All right, and then the one after that comes in is we're going to have a linked list, which is not going to be just connected one way. It's going to be connected forward and backward. It's going to be a double linked list. And then we're also going to have 2 pointers, not just to first, but we're going to have a last also. So you're going to have a ways for you to jump directly to the first and the last. And what we're going to use that for is to create a queue, a priority queue actually. So remember the queue that we did with an array? 2 weeks from now, we're going to make one with linked lists. Okay? And it's going to be a priority queue. So it's going to be double linked, double-ended priority queue implemented using a linked list. And at that point, you should have a complete understanding of how links works, how linked lists work. Okay? And then, yeah.
Any reason why we didn't discuss last in this case? Because last could still identify the last link.
We don't have a last in this particular one.
Exactly, but it couldn't last just be equal to the one that points to null?
The last will be equal to the link that has a next of null.
Right.
Not, last is not going to be equal to null though. Yeah. But yeah, that's the next thing. So it's just, we're starting with one thing, then we're going to complicate it a little bit, and then we're going to complicate it even further when we do the first and last. And the only reason why we would want a first and last, well, not that we wouldn't want to, but you remember how a queue, you only really care what happens on one end or another, right? You only care about people entering at the end and leaving at the front, so that's why you want front, last and first. We didn't talk a whole lot about priority queues, but a priority queue is you insert things in order. So you're going to always be inserting things in ascending or descending order, some kind of an order in this linked list. Okay, so that's what's going to happen for the next couple weeks, and yeah, good stuff. So let's see if there's anything else. Week 7, yeah. So I have your solutions for P5. You can look at that stuff. Yeah, solutions are usually a couple weeks down after the assignment. So if you get stuck, you know where to look. All right. So that's pretty much what I want to tell you about linked lists. Any questions? All right. I didn't take the whole class time this time. So that's all I have for today. If you want to take off, you're welcome to take off. If you want to walk with me to the office hour or whatever it's called, the office, go with me.
I saw on YouTube somebody do an interview and they had to do a linked list.
You saw it? Yeah.
It
No,
was like
seriously.
Google or something.
If you end up getting a job interview for software, I am willing to bet money they're going to ask you some kind of data structure questions.
That's exactly what it is.
And I'm willing to bet money that it's very likely you're going to have to answer questions about linked lists, which is exactly why I'm spending 3 weeks on them.
Yeah. I looked at that stuff a long time ago. I have no idea what it was.
Yep, there you go.
What are they talking about? It was like, some of them were array, like finding something in an array or something. And the other one was like, oh, I'll do this, binary searches and stuff.
Yep.